Hi guys, Mr. Gucci here with your section 2.1 notes, numbers and units. Now, I didn't get through all of section 2.1 with my classes, so I don't know if this video will go all the way through. We'll see at what point do I get tired and just want to give up and make a second video. Okay, let's go. So, numbers and units. So, this unit, we're going to be talking about observations. Okay, now observations are any statements based on observable fact, things that you observe with your five senses and nothing else. It could also include, for example, measurement tools like things that you measure with a ruler or, say, a beaker or graduated cylinder. All right, tools that help you measure things also count as observations, but it can only be things that you observe directly with your senses. Okay, in science, you want to avoid, when doing experiments, you want to avoid making unnecessary inferences. An inference is an assumption based on past experience. So, for example, I did an experiment where I put aluminum foil into a blue liquid and it turned a brownish, orangey color. And a lot of people said it was rust. It was not rust. You were making an inference because you said, oh, this is a metal that turned a brownish orange. It must be rust because that's what I know. It was not rust. You got to be careful about that, okay? Avoid opinions as well. Avoid saying things are good or bad or pretty or ugly in your descriptions, okay? Because it can vary from person to person. It might not be pretty to some other people, okay? What if you say, oh, this reaction produced this beautiful uh, blue glittery substance. It's so beautiful. And then like your other friends like golf, and it's like it's not black, it's hideous. All right, so that's an opinion. All right, keep your opinions out of this. Okay. Next up, there are different sorts of observations. Not all observations are created equal. Some observations are qualitative. Okay, these are any observations you make that are just descriptive, non numerical. Something is warm, something is fast, okay, something is blue or purple, okay. It's called qualitative because it describes a quality or characteristic of something. Other observations are quantitative, right? Quantitative observations, what it sounds like, quantity. It has a number in it. These are measurements that you make that use definitive numbers, like 99.8 degrees, 85 miles per hour. Okay, it describes a quantity. Now, all things being equal, if you have a chance to make a measurement quantitative by including some accurate numbers in there, you're going to want to do so. Not every observation can be quantitative, but quantitative observations are better. Why? They can't as easily be argued with, okay? If you say something is warm, someone else will be like, it's like that's kind of cool, right? It's not that warm. And someone else will be, oh, that's actually really hot, right? Like everyone in your family has like a different shower setting. And like what's hot to one is warm to another. But if you took the temperature of the shower, that's not something that you could argue with, all right? It is the shower is like 120 degrees Fahrenheit. There you go. Okay. You can't argue with that. All right. Also, it's better because you can use that data to solve other things, right? Like how much energy is the water carrying, right? How quickly will it warm you up? If you know the temperature, then you can figure that out. But if we just say it's warm or hot, you can't really. All right. Scientists have actually been really good at taking a lot of things that you wouldn't think could be described by numbers and turning them into numerical values. For example, you'd be like, oh, this T is strong, this T is weak. Scientists have a numerical way to calculate the strength and concentration of different solutions. Even something like, oh, this dress is blue and black. No, it's white and gold. What is it? Scientists have a way to numerically quantify color. Every color has a number associated with it, somewhere between 400 and 750, for reasons we'll talk about later in the year, okay? But you might not be able to make everything a quantitative measurement, but if you have the option, turn it into a number, okay? So here's some sample problems, okay? Here's a description. You tell me, is it qualitative, quantitative, or neither? Let's go through some of these. The sample changed from silvery to reddish brown. Qualitative, quantitative, or neither? It's qualitative, all right? Because you're just describing a characteristic of the substance, something non numerical but still factual that you observed with your eyes. So this right here is qualitative, all right? That was my cat, okay? The reaction produced a pretty colored smoke. Qualitative, quantitative, or neither? Neither. Okay, the fact that they're saying this is pretty, that's an opinion, all right? Smoke is different to different people, okay? And also, do you even know it's smoke? Smoke is a very particular substance. It's the product of burning things, actual the combustion reaction, all right? It's the release of ash particles and toxic or at least unbreathable gases. That is smoke, okay? What's being released might not be smoke. It could be some other gas that is not smoke. In fact, if you were to say, oh, Mr. Gucci, when you mix bleach and ammonia together, you make this beautiful light yellow greenish smoke. All right. Well, first of all, okay, that is not smoke. That is toxic chlorine gas. It will kill you if you breathe in enough of it. And second, because I know it's toxic chlorine gas, I do not find it beautiful at all. I find it frightening and I get the heck out of there. Okay? So here's another one. The reaction produced 15.7 grams of powder. Qualitative? Quantitative? Neither. This is quantitative because it has that number in there. It's a numerical measurement. You're not saying you produced a lot of powder or a little powder. You're telling me exactly how many grams of powder. Okay. And that's useful because we can't really argue with this number. And that's a number that we can use to do calculations. Oh, we produced 15.7 grams of powder. Is that as much as we were expecting? Did we produce a little extra? Did we produce a little bit less? Now we can work with that. Okay. Cool. Now, every number needs a unit attached to it. Like if I said, oh, we have a test in 5, is it 5 minutes and you should start panicking? Is it 5 days and you should review your notes? Or is it like 5 months? Like, hey guys, the AP exam is in 5 months, in which case you're like, I don't really care. Units are the difference between panicking and you got plenty of time. Okay, so units are important. And in this class, we are going to use the International System of Units, or SI units. It's the modern version of the metric system that you are familiar with: grams, meters, liters, things like that. Okay? Everyone around the world, except for like us, Burma and Liberia, uses the metric system. Okay, so in every other country except for us and those two, they wouldn't even have this section. You'd be like, well, I introduce you to the International System of Units. And they're like, you mean units? All right. We got some stupid units. We got our units from England, and not even England uses those units anymore, guys. Think about that, okay? Now, what makes the International System of Units great is that every type of measurement has a base unit, okay? So it's not like in the English system where it's like sometimes length is an inch, sometimes it's a foot, sometimes it's a mile, all right? No, in the metric system, distance is always about meters. It's always meters, but they'll add prefixes in front to change the scale. All right. So if we're talking a lot of meters, then we'll switch over into kilometers or kilometers. If we're talking not even 1 meter, then we might be switching over to centimeters or 1/100th of a meter. These are the common international system units right here. Okay, we've got the meter, symbol M, and that's a little bit more than a yard, a bit more than 3 feet. So a soccer pitch, I think, no one, I don't watch soccer, so someone correct me. A soccer pitch is like 100 meters long. A football field is 100 yards long. That's pretty much the same. Football field is slightly longer, though. The mass for international system is gram, is how they measure mass, symbol G. 1 gram is equal to about a skittle. So if you're holding a skittle, you're holding a gram. If you're holding 1,000 Skittles, that's 1,000 grams. Time, they use the second. Fun fact, this system was developed by the French. They started to do this during the French Revolution when they wanted to get away from like the old way of doing things and find a more sensible way to set up measurements and stuff. Like they didn't like the English system because it was all based on like what the king's decree. They wanted a more sensible unit. The French revolutionaries actually tried to create a new version of time where like there were 100 seconds in a minute, 100 minutes in an hour, and like 10 hours in a day. And that just didn't go over well because so many people had these nice clocks and they didn't want to like throw out their clocks. So their special time system didn't take, so everyone uses seconds. Okay. Temperature is Kelvin, which is a different version of the Celsius temperature scale. And volume is liters. All right. And that's probably the one you're most familiar with because of these guys right here, right? A 2 liter soda bottle. It's got 2 liters in it. If we look on the bottom here, we'll see that it says, hey, 2 liters. All right. AKA 67 0.6 fluid ounces or 2.1 quarts. All right, those ounces and quarts are dumb American units. They're dumb. Okay. So, and these are the prefixes. All right. If you want to say that something is 1,000 times bigger, you put kilo in front of it. A kilogram is 1,000 grams. A kilometer or kilometer is 1,000 meters. Okay. You could even say something like you probably haven't heard of, like a kiloliter, right? Like I drank a kiloliter of soda. That's like 1,000 liters. That's 500 of these. So it's a thing. No one really uses it. All right. Centimeter. All right. Centimeter is 1/100th. Okay. You put centi in front of something to divide it by 100. You put milli in front of it to make it 1/1000th. Now there's other prefixes. All right. Other prefixes do exist. Um, they just aren't as common. All right. So, for example, if you put mega in front of something, that means a million. All right. So, if you say a megaton bomb, it literally means it's the equivalent of setting off 1,000,000 tons of TNT. Okay. Micro means divided by 1,000,000. So, if someone's like the microscopic, they literally mean the scale of 1,000,000th of a meter. All right. 1,000,000th of a meter. Hecto is 100 times bigger. Deci is 10 times smaller. You like rarely ever heard of these things. Like you will occasionally hear deci, but like never. Okay. These are the big three. It goes bigger than mega. And if you're like familiar with like computer memory and stuff, like, oh, you got a kilobyte, which is 1,000 bytes. A byte, by the way, is a unit of information. A kilobyte is 1,000 of those little pieces of information, 1,000 bytes. A megabyte of memory is 1,000,000 of those pieces of information. After megabyte is gigabyte. Okay, gigabyte is 1 billion. After giga is terabyte, which is 1 trillion. All right, and it keeps going. Right, Google's got like petabytes, which is like quadrillion. It's big. It's big. Don't even fret. Okay. So again, these are the most common units, and these are the common prefixes. And once again, it makes things so much easier. Like for the imperial system, which is what we use, okay? There's 12 inches in a foot, all right? And there's 5,280 feet in a mile. So if I ask you how many inches are in a mile, well, guess you're taking out your calculator because these are stupid numbers, okay? Why are they like this? History, all right? I don't know. Like I was talking to Mrs. Levin, and she was saying like a pound was however many marbles the king could hold with his bare hands. That is just the dumbest way to base any measurement system. What's a foot? It is the length of the king's foot. All right. Well, what about a new king? Well, the foot changes. Like, just kill me, please. This is terrible. All right. But that's not imperial. That should say the metric system or the international system. You're gonna quit out on me here? We're gonna do this. All right. Yeah. The let's call it SI units. Right. Okay, yeah, for SI units, it's like much simpler, much simpler. Okay, there's 100 centimeters in a meter and 1,000 meters in a kilometer. So, how many centimeters are in 1 kilometer? 100,000, 100 times 1,000. It's 100,000, right? It's even easier when you get to like volume, right? There's 3 teaspoons in a tablespoon, 2 tablespoons in an ounce. 8 fluid ounces make 1 cup, but 2 cups make a pint. 2 pints are a quart, but 4 quarts is a gallon. How many teaspoons are in a gallon? You're fired. Get out of my house. Stop asking me these damn questions. Okay, I'm not changed yet either. I'm not gonna get. Yeah, I'm gonna change it. I'm gonna change it. All right. No, I'm not. I don't care. All right. So look, whereas in the, block that off on top there. All right. Oh, I know. I'm so clever. Whereas in the SI system, whereas in the SI system, all right, it's 1,000 milliliters equal 1 liter. That's it. How many milliliters are in a liter? 1,000. Okay. Like how much simpler is that, right? Like why aren't we just doing this? The only reason why this stuff over here, the imperial system, is like slightly easier to you is because like you've used it your entire life, okay? And like if you went to a European and you introduced like our imperial system of volume measurements to them, they're like, that's like some Harry Potter nonsense, right? It's like, oh, there's 32 nuts to a sickle, 17 sickles to a galleon. We sound like we're a bunch of morons, okay? They tried switching over the country to to metric, it just didn't go well. We're stubborn. See, how well is asking Americans to wear masks going? All right, ask yourself that. Okay, and that is why we don't use metric in this country. God damn. All right, I'm stopping this video. I said I'm stopping this video.